Hello there, this is Jeff Herdman, E.D.S. Inc. Shandon, and welcome you to another episode. Today we're going to start on a new adventure, new project for me, something I've never done before. I plan to do it, so we'll see how it comes out. What we need is a bigger dust collection system because we got a pretty immense sander, and we're going to need about 5,000 cubic feet per minute evacuation of our dust. So I've been sourcing those, and they're pretty expensive. And I had a bid in on one, and the pricing got quite a bit more than what I wanted to pay. And I thought, I've got the motor, I've got an idea how I could build the fan. I was going to cast it, and then I thought, nope, I'm going to go ahead and I'm going to build it. So that's what we're going to do in this episode, is we're going to build the fan. As we move forward, we'll show you how we put the whole thing together. Hopefully I'll get all that on video. Sometimes it goes so hectic around here, and there's so many things to do that I have to have the guys in the shop to get some of the stuff done, and it gets done without video, and thus I'm not able to show the completion of it. My demands are typically in the office most of the time. I spend most of my time staring at a computer processing projects, so it's not fun. I'd rather be out using my hands. That's what I've done all my life, but that's what has to be done in business sometimes. So that's what I do. So typically when you see these videos, it's after hours or on the weekends that I'm doing this, when no one else is around the shop, because when there's somebody else here, right now with that, our COVID-19, we have to deal with wearing masks when other people are present. It doesn't make it very comfortable, and to do a video, and that way I can express myself more clearly to you without the muffle of a mask on my face. In regards to the dust collection system, I have a motor that will do the job for me. It's a 10 horsepower motor. I have a turret, not a turret, a cyclone that will, I'll have to modify it a little bit, but for the most part it'll accept the volume that I'm expecting to put it through. So what I'm going to have to do is develop a basin for the dust. I have a 4-bag system, so as the air leaves the cyclone, it can be filtered by the 4-bag system. And then of course out the bottom of the cyclone is where all your dust drops, and I need to make some place for all that dust to go. So with the space constraints that I have, so I'll be building something for that. So what I'm focusing on right now is the fan itself, and once I get the fan built, we'll get it mounted to the motor, and then I'll design the rest of the system around that, the housing and stuff for the fan, how the motor's going to mount, and all that will be done after I get this component built and we get things more exact there. So that's what we're going to do. I'll take you over to my Bridgeport. Over here I've got the aluminum laying on here. What we're going to do is we're going to have one base piece of material. Is currently 1.5 inch thick aluminum, 6160, and I'm going to actually weld the fins into it. They're going to be notched into it, but I'm also going to weld them into it. So to do that, I had to order a spool gun for my welder, and so that's coming. Hopefully I'll have that in the next week. and so that we can feed do our aluminum welding. My TIG welder doesn't do aluminum. It's a DC unit, so I can't do aluminum with it. So I'm going to MIG weld it. Spray weld, I guess, is what the process is, and that'll be a new adventure for me. So I'm going to have to do some research on that, do a lot of practicing, and then I can proceed with that once I get the knowledge that I need and do enough practicing to be confident that I'm going to put down a nice, good bead in this. So there's a bunch of processes. This is going to take a little while, so we may have a video this week on this and something else the following week, and then get back to it again. We'll see how that works. Like I said, I'm doing this on limited time, so I've blown a whole lot of hot air at you. Don't expect this whole video to be about me gabbing. So why don't I take you over to the Bridgeport here. I'll show you my layout, what I plan to do, and we'll go from there. Okay, so this is my layout that I have here. Let me grab something I can point with. So I use this center point here on my Bridgeport to draw this and do a layout so that the layout could be accurate. So basically this is my outside perimeter. This is, I think it's 19 3/4 if I remember correctly. And what it was is I'm trying to get the most out of this piece of aluminum. I probably could have made it a little bit bigger by bringing it over this way, but I was concerned about this existing hole here that I need to mill out, and I didn't want it to interfere. And I always make mistakes, so I figured that at any rate, this is the way I laid it out. And so we're pretty much to the edge over here. We've got about an inch to spare over here. So I could have moved it over another about 3/8 of an inch is what we have right here. But when I started laying it out, I just said, no, just leave it where it's at. So anyway, this is the Arbor hole here. It's about 1 5/8 inches. And so that'll be a through hole. This here is what I'm calling the shoulder of the Arbor. So basically this is going to remain full thickness of the material. It'll be a full 1.5 inches, and we will be drilling and tapping this out to accept a Allen screw to fasten the fan onto the Arbor. I'm also going to have to broach a keyway into this. So I believe that I have enough diameter that I could do that on my press. If not, I may have to set up my slotting tool on my Ajax mill and slot a broach in there. So we'll just have to see what comes about here as we go along. And this is kind of by the seat of my pants venture. I've been thinking about this for probably 1.5 months and developing a design in my mind, but I've never put it down on paper. And I have to use the materials that I have here in the shop. So this was the cleanest piece of aluminum I could find in my scrap pile. So this is what we're using. So that's what constrains the width of this. I wanted to have 20 inches. We're not quite going to have 20 inches across. So that's what we're going to try to achieve. So the shoulder is going to remain the full thickness, and we'll round off these edges all the way around. And as you can see, these are going to be the fins that go into it. The base around this will be lower. We're going to take that down almost 7/8 of an inch. And that's so that we can get that set screw in through this material and holding down this fan to the Arbor. So so that's one of my issues that I'm going to achieve. And what I'll probably do with this, since this is aluminum, I'll probably put a set screw down, and it'll be a short set screw, and it'll tie this together, and then I'll run another set screw over the top of that to lock that set screw in place. So that's what my thought process is on that situation. That way, because aluminum's soft, and I'm just afraid that I could eventually strip out that screw, and I don't want to do that. I want to keep it tied in there. So, like I said, I'm going to take this down in these areas down to where the material is only 7/8 thick. So we'll be taking off 5/8 of an inch out of here. And I'm going to try to attempt to use a bull nose mill and finish this off with a bull nose mill all the way around here, so we have smooth radiused surfaces instead of sharp features on this wheel. And when I'm all done, I'll bull nose the whole diameter of this as well. Again, to soften all the features of this fan. And then what I'm going to do, and with already you can see how I've offset these. These aren't based off of center. They're 1 inch off center. And that gives kind of an angle to them, and it helps with the sweep of the fan. But to help it even more, when I, let's see if I can find something to show you what I plan to do. Okay, this is a pretty thick piece of aluminum, but to give you an idea, I'm going to angle my Bridgeport head so that when I groove these out, I groove that groove at an angle. And then I'm going to slip the slats into that groove, and then I'll weld the slats of the fan in. And that way is capturing the air as it flows by, and as it comes into the duct that it's supposed to expel it from. Basically, the intake is going to be here. It's going to be like in this perimeter, and it's going to be 18 inches, I believe the intake is. And then we have a duct that goes out from one end or the other that is your outlet, and that's where your dust heads out to. So basically it sucks everything from the center and sends it out, and the rest of this will be enclosed. And the blades will be tapered down to this knuckle, so that it sucks the sawdust up into that housing that will be the exit for the dust. So that's kind of the thought process that I'm putting behind it. The fans, they'll all have radiused edges on them, and as well. So that's my theory. That's what I've put together in my mind, and that's how we're going to develop this thing. So unfortunately, I don't have any bits that I can drill this out with that are 1 5/8" diameter, and I wouldn't want to drill just a straight hole anyway. I'd want to ream this out more. I don't have a reamer of that size, and I can't put this in my lathe, because if I had the Monarch running, I'd be able to install this into my lathe and do all this on the lathe, but not all of it, but do a lot of the processes on the lathe. But since I don't have a lathe that has this capacity, I'm a little bit stuck. So I have to use what I've got. Now, once I take all this down 7/8 of an inch, I might be able to get a lathe on this. But the problem is, this is the side I need to work on. so that won't do me any good at all. So I'd have to probably make a arbor and put it on an arbor to spin it on the lathe. So that may be what we'll do to take this material down. I have not decided that yet. But to get this hole in the center, what I'm going to do is get my biggest mill and run it down through the center. And then I've made myself a tool, if I can find it. I should have had that all ready for you. So I've made myself an arbor out of, this is some bar stock that I had in my lathe, or some of the lathe tooling. And what I've done is I've drilled a hole through it here, drilled and tapped this side so that I can put a cutter in here. And what I've done, this is a carbide end mill, and what I've done is I've made a cutting edge on this tool that will clean up this edge for me. So I'm going to go ahead and drill this out, or with a mill, to within maybe 3/4 thousandths of my line, and then I'll use this bit and this mill to take it to size. That way I get a nice accurate hole down the center for my arbor. And I'll be checking this over and over as I go, because we want to make sure that this will fit that arbor when we're all done. I've double checked the arbor size. Originally I thought it was 1/11/16 until I took my micrometer over there and measured it. I was trying to measure it with my Starrett caliper, the digital caliper, but it was really hard to get where the motor's sitting. It's really hard to get in there, and I had a really hard time getting an accurate dimension. Whereas with the micrometer, I was able to get that in there and get it locked in place before I pulled it off the arbor. And whereas with the Starrett caliper, digital caliper, I couldn't turn that little knob and keep it locked in place. I'd always move it. So I originally thought that this dimension was 1/11/16, but I found that with the micrometer that it's actually 1 5/8. So so that's what we're going to drill out of here. Okay, we're going to go ahead and drill this out. I've got about a 120 mil there. Must have mismeasured that when I started it. Let me brush this off. I'm going to want to go a little bit past the bottom of this. We'll be going into this other plate about about 3/4 of an inch. So I'm going to set what I believe that one should be about right there. That's close enough. I'm going to set that as my 0. Okay. So 1. Well, that doesn't make sense. It shouldn't be through yet. And that may not be. 1, 4, 6, 7. So it's not quite 1.5. But I'm not there yet. Cut through and it's just sitting on the bottom, so I have to pull the cutout out of there. Put something down there to fish that out, because otherwise what will happen is the cutter will just keep slipping on this silly thing. There we go. See, that's what we had in there at the bottom. So what would happen is the cutter wouldn't be able to cut. It'd just spin on that thing. So we need to get that out of there to cut any deeper. Now, I'm trying to think of what I want to do here, because I have a slug in there I could pull out actually, but that would be somewhat hard, wouldn't it? I'm trying to remember which side was bigger. We'll just go ahead and cut her down. I need to take another 3/4 of an inch. What? That's going to take me all the way down to where I need to be, though. Nope. I can do it. I can do her safely. So we'll take this down. I'm going to reset my 0. And we're going to take it down just 3/4 of an inch. So basically I'm cutting down into my plate below this one 3/4 of an inch so that my tooling can get past it. So basically I have about 3/4 of an inch from the end of this to the cutting point. So I need to have that much more draft so I can get past that. Now we're going to widen our hole now, turning it on the rotary table. Okay, we've been around better than 360. I'm taking it back to 0. Locking my table. And I'm on 0. We'll pull her up. So some of you might be wondering, well, why didn't I use the rotary table to get to my finished cut? Well, I don't know if you noticed it, but as I was turning the table that I have is not the highest quality, and there was a lot of movement in there, so I wouldn't have gotten a true circle for my arbor, and so I want this to be cleaned up the way it should be. So that's why we went ahead and we processed this all the way through. I got a pile of junk down here. Let me grab that with the vacuum real quick. That's cleaned out. So by using a boring bar, I can adjust it out to where I'm cutting right to my desired depth, and I'll have a round circle all the way down for my cut. So that was the whole idea of that and the whole purpose of it. So to answer any of your questions in that regards. So now we're going to take this and offset the table. I won't bore you with that, and put our bit in here that we're going to use in the milling machine, and then we'll proceed with our next process. So this is an old carbide bit that got broken off, and I hand ground this, and on the bottom side of it I ground a flat in it so that the set screw would keep it in the position it needs to cut. I believe I've got the angles right. This is the first time I have ever cut a carbide bit for a, I guess you could call this a boring bit or a fly cutter, whatever you want to call it. And so hopefully I got it figured out right, and I've got the cut right. I'm looking at it now, and I may have the rake a little bit lower than it should be, but we'll start to cut, and if it looks like it's balking, I'll readjust it, and we'll come back to it. Yeah, it's balking a little bit, so I need to change the angle of that. So I'm going to shut you off while I readjust that bit. Okay, so I've readjusted the angle of the cutting head, and we'll see what we got now. That's much nicer. She's cutting very well. take a dimension on this. Okay, I'm going to, I think I'm going to have to move this whole table this direction so that we can get a dimension on this. Man, that feels nice. I like that. Okay, I'll bring you back as soon as I get this out of here and I can measure it. Okay, so we got this inside diameter here. Let's see, let's take her over here. And you can see we've got a little ways to go. About 30 seconds of an inch. So we've got a little bit more overclean out there before we're done. So I went back out and I remeasured this and locked this. So what you can see here is that we're still about 3/30 seconds off in our dimension. So we've got a little bit more to take out. I just wanted to double check the shaft. It's better to measure twice. And I found out that it was a little bit wider than what I originally anticipated. I said it was 1 5/8. I'm getting just a little bit over that, 25 thousandths over that dimension. So so that could be just a bunch of dirt and crud and knots, and you know the shaft may have been banged around, and I might be measuring on a high side. Where the unit is at, it's really hard to get to, and is hard to measure. So I took several shots at it, and each one of them came up the same. So I'm going to call it as being an oversized shaft. And so I'm going to make this cut an oversized cut to accommodate that shaft. So we'll go ahead and we'll get this recentered, and then we'll get back to our cut. Okay, we're going to go ahead and make our next cut. Any further, because I can always reset my tip if I don't have it right. Now let's see what we got here. Just a tad bit big. I'm going to have to bring it in. I'm glad I checked that before I proceeded. So let me reset that tip and vacuum this out, and we'll see what our dimension is, huh? Boy, she's shining up real good down in there. Real pleased with that. She's doing a real fine, beautiful cut now. So I got that angle correct this time. And the problem is when you're using a round insert like that, and you're using a screw to tighten it, you can get off just a little bit one way or the other, and you need to try to get that angle adjusted right so that you have a nice clean cut. And man, she's pretty all the way down there. She's just as pretty as can be. Okay, let's get down here and see where we're at. Let's see what we got. Still, we need to trim a little bit more off. So I'll reset that tip. It just takes too long to do while we're on camera here, so I'll just readjust that and then bring you back. Okay, now the angle on this tip looks at the right angle, and we can proceed. I have to say that I'm not trying to brag or nothing, but this is just, there was some chatter too. You could hear the, not really chatter, but harmonics. But man, it didn't affect the finish at all in there. It's just as shiny and pretty as could be. Let's check our dimension. Okay. Okay, so what we got now is 625 and just slightly over. What do we got there? And it's a 2 and 2/1000. So we're just 303. So I overshot a little bit, but that's okay. That'll allow that dirty shaft to fit in there because there's not any real strong highs or lows. So I think we're going to be good. I think that this is going to be just perfect. We're about 25 is 2/1000 over, really, is all we are. A little bit over 2/1000 over. So I think that that is a perfect fit myself onto a shaft. That'll make a nice slip fit, and that's what we want. So we achieved our goal. Okay, so here's a view of the hole. And you can see really clean. This is my first cut that I cut too wide in here, but you can see the rest of that hole down to the base is just pretty as can be. And this is the little cutter I used right here. My first time making a boring bar, and or a fly cutter, whatever you want to call it. I'm not sure what you would call it. I wasn't face milling. I was boring a hole. So again, thank you much for watching. Well, thanks for joining E.D.S. Inc. Shandon tonight. We appreciate your viewing. and I hope that you enjoyed this. This is the first time I've ever taken a broken bit and manufactured it into a cutting tool. Or even made a boring bar. I've never done that before. But I've watched some of the other fellows on the YouTube channels do that, and it didn't seem like it was too big of a deal. So the way I did that is I bored the end hole on the lathe, and then the hole that went down through the shaft that the cutting part went into is actually I used a bit that was the same size as the one that got broken off. So in doing that, I was able to have a really nice tight fit of that part that broke that I used as a cutting tool. So then I hand ground that. I've got a little grinder in the back, a diamond stone grinder, and I ground that and then honed it down some. The big trick was trying to get the angle correct when I'm moving it in and out. My flat on the back was slightly off, and so it kept wanting to take it back down to the wrong angle. So I've got a little bit to learn. It'll make it a lot easier when I get my tool cutter set up and I can do things more precisely. Doing it by eye and hand is not an ideal thing to do on a small, especially a small part like that. It's hard to hold and it's hard to control the cut. So I did the best I could, and it turned out I'm just really tickled because the finish is just beautiful down through that shaft. It feels very smooth to the touch, and so I think I did a pretty fine job. Some of those fellows out there that do this all the time might think, well, you're a clown, but that's okay. I'm learning as I go. I want to thank you for watching this video. We've got a lot more to do. That was just one hole on this whole apparatus, and we've got a whole lot more work to get done on it. And like I said, I'm not sure if the next video will be on this or something else that we're doing here in the shop, but we'll take you along for the ride through this whole process, hopefully, and you'll get to enjoy it. So thank you very much for watching E.D.S. Inc. Shandon, and tune in the next time.